Hello students, in previous lecture we have studied characteristics of semiconductor digital ICs and TTL NAND gate. Today we are going to learn about TTL NOR Gate 7402 device. This is another universal gate and this TTL NOR gate circuit can be obtained from TTL NAND gate. Students, if you observe carefully this TTL NAND gate circuit, in this TTL NAND gate circuit only transistor T1, T2, T3 and T4 are present here, but in case of this TTL NOR gate, only transistor T5 and T6 are added. Is that clear, students? See here, this is transistor T1, like T1 in NAND gate, here T2, same here in NAND gate, T3 and T4, this is totem pole stage here, but in addition only T5 and T6 are, you can see the change in this diagram. Okay, now let us see working of this TTL NOR gate. In this TTL NOR gate, here transistor T5 and T6 are added. And if you observe carefully, here transistor T2 is driven by transistor T1 and T6 is driven by transistor T5. Okay, students? And here transistor T2 and T6 are in parallel. That means it is clear that when either of transistor T2 or T5 is on, so the base of transistor T3 goes low, and as the base of transistor T3 goes low, at the same time due to this transistor T4 is at high. Okay, students? Because when transistor T2 or T5 switches on, and we know that as the transistor NPN transistor switches on, its collector goes to the low. It will make the base of transistor low. As the base of transistor is low, it will make the transistor T4 off. And as the collector goes low, here emitter is high, therefore transistor T4 is high. When both the transistor T2 and T6 are in cutoff, and we know that when the transistor are in cutoff, its collector will goes to the high, and this high collector is given to the base of transistor T3. Thus, this transistor T3 switches on. As here collector is high, so emitter is low. This lower emitter potential is given to the base of transistor T4. Therefore, this transistor T4 goes into cutoff. Okay, students? Or we can say that if transistor T3 switches on, this transistor T4 switches off, or vice versa. Okay, students? When we consider case 1, A is equals to 0, B is equals to 0. A0, B0 means this emitter of transistor T1 is at lower. In the similar way, emitter of transistor T5 is at lower. Therefore, at this time, both the transistor T1 and T5 becomes on. I repeat again, when we consider first case, when A0, B0, at the same time transistor T1 and T5 becomes on, and therefore this T2 and T6 goes low. Why, students? Because when both the transistor switches on, its collector goes to the low. For example, if the collector of this T1 is lower, it is given to the base of T2. Therefore, it will makes the T2 cut off. Okay, students? Therefore, in the similar way, when T5 is switch on, its collector goes to the low and it is given to the base of transistor T6. It will makes this transistor T6 cut off. Okay. As transistor T1 and T5 switches on, its collector goes to the low. As the collector of transistor T1 and T5 is at low, therefore it is given to the base of transistor T2 and T6. Thus, transistor T2 and T6 goes into cutoff. Okay. As the transistor T2 and T6 are in cutoff, its collector goes to the high. If the collector voltage VCE is at high, it will make the transistor T3 on, because as the base of transistor is high at VCC, therefore T3 becomes on, and we know that as T3 becomes on, T4 becomes cut off. Okay students, therefore we can say that the output for this first case, when A is equal to 0, B is equal to 0, will get output Y is equal to 1 or VCC. Okay students. Now I repeat again, when A is equal to 0, B is equal to 0, at that time transistor T1 and T5, here transistor T1 and T5 switches on. As the transistor T1, T5 switches on, its collector goes to the low and it is given to the base of transistor T2 and T6. Thus, transistor T2 and T6, you can see in this truth table, transistor T2 and T6 are in cutoff. As transistor T2 and T6 are in cutoff, transistor base of the transistor T3 is at high or positive VCC. Therefore, as the base of transistor T3 is at high or positive VCC, this transistor switches on. Therefore, at the same time transistor T4 is in cutoff. Thus, we'll get output Y is equal to 1 for this first case. Is that clear students? Now, let us see case second. In case second, students, if you observe case 2, case second, when A is equal to 0, B is equal to 1. And in case 3, when A is equal to 1, B is equal to 0. Means we can say that when either of input is high, means when A is high or B is high, one of the transistor T1 or T5 becomes cut off, and as one of the transistor T1 or T5 becomes cut off, it will make transistor T2 or T6 on, and as the transistor T2 or T6 switches on, the collector junction of transistor T2 here or T6 goes low. As the collector junction of T2 or T6 goes low, its collector voltage is low and it is given to the base of transistor T3. Therefore, the transistor T3 is in cutoff, and as the transistor T3 is in cutoff, at the same time transistor T4 is switches on, and we'll get the output Y is equal to 0 or ground. Students, you can check the possible combinations for case second and case 3 with the help of this truth table. Okay students, here when A is equal to 0, B is equal to 1, A0, B1, if A is equal to 0, it will make transistor T1 switch on. As the transistor T1 switches on, its collector goes to the low and it is given to the base of transistor T2. Therefore, transistor T2 now is in off state. Okay, now when B is equal to 1, in case second, it will make transistor T5 cut off. As transistor T5 is cut off, its collector is given to the base of transistor T6. As the transistor T5 is off, its collector is high and it will make transistor T6 switches on. And when transistor T6 switches on, its collector goes to the low. It will make transistor T3 switch off. Okay students, and as at the same time transistor T2 also off, because collector of T1 is at low. That's why this T2 is in off state. Okay student, so T1 switches on, it will make T2 switches off. As T5 is in off state, it will make T6 on, and due to this all the conditions, transistor T6, as the transistor T6 on, its collector goes low, and transistor T3 is in off state. As transistor T3 is off, so the transistor T4 is on, and as transistor T4 is on, its collector is low, thus we'll get for second case Y is equal to 0. In the similar way, when A is equal to 1, B is equal to 0, this condition reverses here as compared to previous case. Means here transistor T1 is off while transistor T5 is on. As transistor T5 switches on, its collector goes low as the collector is given to the base of transistor T6. Therefore, it will make the low collector of transistor T5 will make transistor T6 off. As the transistor T6 is in off, its collector is high and it is given to the base of transistor T3. Okay students, as here this collector of transistor T6 is here given. Now here transistor T1 is off. When transistor T1 is in off, its collector goes to the high. It will make transistor T2 switches on. And as the transistor T2 switches on for this third case, its collector goes to the low. It will make transistor T3 off. Thus, when transistor T3 switches off, it will make transistor T4 on because here T6 is off. Okay students, as T6 is off, its emitter is given to the base of transistor T4. Therefore, transistor T4 is on, and thus as the transistor T4 is on, its collector is low and it is nothing but the output Y. Therefore, we can say that for third case, still this Y output is 0. Okay students, now let us check for this fourth and last case. In last case, when A is equal to 1, B is equal to 1, when the emitter of this transistor is at high, in the similar way, the T5 emitter is at high. So, both the transistor T1 and T5 becomes cut off as both the transistor T1 and T5 becomes cut off. Its collector goes to the, okay students, its collector goes to the high as the collector of T1 high, it will make collector of T1 is high, so it will make base of T2 is high. As base of T2 is high, it will make transistor T2 on. As the transistor T2 on, as the transistor T2 switches on, its collector goes low. Here in similar way, T5 also off for this third case. When T5 is in cutoff, it will make its collector high, and as the collector of T5 is given to the base of transistor T6, as base of transistor T6 is high, its collector goes to the low and it is given to the base of transistor T3. It will make transistor T3 off. Thus, as the transistor T3 off, due to this condition, transistor T4 is off. Transistor T4 is on because the emitter of this transistor T6 is at high. Okay, if the emitter of this T6 is at high, it is given to the base of transistor T4. Thus, if the transistor T4 switches on and transistor T3 switches off, we'll get Y output is equal to 0 because when transistor T4 switches on, its collector goes to the low or ground. Is that clear students? In this way, this is the working of TTL NOR gate. Now students, as you can check the combinations for A1, B1 this last case and on-off conditions of transistor T1 to T6 with the help of this truth table. Okay. Here A1, B1 transistor T1 is in off state, so T2 is on. In the similar way T6 is off, so T6 is on, and as both the transistor switches on T2 and T6, therefore due to the lower collector it will make base of the transistor T3 lower, therefore this T3 is off and T4 is on. Okay students, in this way today we have completed the working of TTL NOR gate. Now this is time for assignment. Paper 2, chapter 3, assignment number 1. Question 1. Explain any 3 characteristics of semiconductor digital ICs. Students, this question carries 3 marks. Question number 2. Draw the neat circuit diagram of TTL NAND gate and explain its working with truth table. This question carries 4 marks. Question number 3. Explain the working of TTL NOR gate with neat circuit diagram and truth table. This question carries 3 marks. Students, complete this assignment in your notebook and send me in PDF format. Okay students? So today we have studied TTL NOR gate, and in next lecture we'll see MOS technology and different type of MOS family. Okay students? So that's it for today. Thank you.